So we are going to be talking about circles today, and parts of circles what we call sectors. So to define a circle is a set of points that are equidistant equidistant, that means equal in distance, the same distance away from, that's what that means. From a given point, which is called the center. And we always identify the center by putting a little dot in the middle. And a circle is named after its center. Okay, so it says circle P. That would be, we would put the dot there for the center and we would put a P next to it. That's how I know it is called circle P. Okay, so you have your center. The circle is formed by all of the points that are the same distance around, same distance away from that center. All right, and then a radius is one of the main things that we're going to be using, especially for area. And that is a segment with end points at the center and on the circle. I'm going to draw that after you fill those words in. And I'll draw the radius in your picture. Bless you. A radius is a segment with end points at the center and on the circle. So here's what a radius looks like. Here's my center. The radius is going to go from the center to the outside edge of the circle. That's what they mean, from the center to the edge of the circle. Okay, a radius is only halfway through the circle. Then you have the diameter. And a diameter is a segment that passes through the center, but it goes all the way through from one edge to one edge. Okay, so here's my center. My diameter is going to go all the way through. And then pay attention to what it tells you at the very end. Your diameter is 2 of your radii. Okay, so if you have your radius and you need your diameter, you just multiply it by 2. You just double it. Okay, everybody understand the difference between a radius and a diameter? Yes, no, maybe. Yes. Okay. So we're going to be finding 2 things. We're going to be finding area. So think about this. Think about a pizza. Your area is going to be all of the toppings that cover it. Okay, how much it's going to take to cover. Or a table, a round table. A tablecloth would cover that. Okay, so that covers the area. The circumference is the distance around that circle. Okay, how far it is around. So think about on your cars, your tires. One rotation of a tire, that is going to be the circumference of that tire. Okay, area covers it, circumference is around it. 2 formulas. Again, I will give you all of the formulas that you need. But for the area, your formula for a circle is area is equal to pi times your radius squared. Pi r squared. And then the formula for circumference, there are technically 2 of them. And it really depends on if you're given the length of the radius or if you're given the length of the diameter. So if you have the radius, your formula would be 2 times pi times radius. And then if you're given the diameter, your circumference is just pi times diameter. You choose which formula to use based on whether you're given the radius or you're given the circumference. In all of our circles, we we are going to leave our answers in exact form. Okay. And what that means is I'm not going to actually use the value of pi, the 3.14. I'm just going to leave the pi symbol in it. Okay, so when it says exact form, you leave the pi, that symbol. Everybody ready? Sure, can't wait. So excited. All right. All right, quick question. In number 1, am I given the radius or the diameter? Radius. Okay. So let's start with the area. It asks us to find the area and the circumference. So we're going to start with the area. And again, the formula is pi times radius squared. Okay, so let me ask you this. What is the length of my radius? 12. Okay. So what I want you to do when you're finding the area is find that number, your radius, and square it. We don't need to worry about the pi symbol. We're going to leave that in our answer. So if you're not sure what 12 squared is, do it in your calculator. And that gives me how much? 144. And then what we're going to do is we're just going to put pi behind that, and that is exact form. That's what I mean by leaving the area and circumference in exact form. You just figure out the numerical value and you stick that pi symbol behind it. Everybody know that? Mm-hmm. Now we're going to find the circumference. Now, you told me I had the radius, so we're going to have to use the formula that has an r in it, and that is 2 times pi times radius. So what we're going to do is fill in that number. Your radius is 12. And let my tablet catch up. What we're going to do for exact form is we're going to just multiply the two numerical values there. What is 2 times 12? 24. And then we leave that pi symbol, and that is how we're going to represent our circumference. All right, look at picture number 2. Am I given the radius or the diameter? Diameter. But for the area, I have to know what the radius is. I'm going to let you do the work after we discuss this. If the diameter the whole way across is 18, what would the radius be, which is only halfway across? 9. Okay. So your radius is 9. Find the area. Plug it into your area formula, pi r squared. We're going to leave it in exact form. That just went off there. Once you find your area, go ahead and find your circumference. Once you have the area, find the circumference. And in this case, you can either use the radius or the diameter and use either circumference formula. That is up to you. Either one, because you have the diameter or the radius, so it doesn't matter which one you use. You should get the same thing. If that's what you're used to, then yeah. Okay. All right, for area, it is pi times radius squared. What is the radius that we figured out? 9. And what is 9 squared? 81. So the area for this circle, we're leaving it in exact form, is 81 pi. With circumference, I can either use the 2 pi r, because I know what the radius is, or I can use pi times diameter, because I also know what the diameter is. Either way, you're going to get the same thing. If I do 2 times pi times my radius of 9, okay, remember 2 pi r, whoops. What's 2 times 9? 18, okay. Or, if I use the circumference was equal to pi times diameter, what did we say the diameter was? 18, so isn't that the same thing? Either one of those. Circumference formula doesn't matter which one you use. Is everybody kind of okay with that? All right. Now, we're going to do a couple of questions where we have to work backwards. In the directions, what is it asking me to find? The diameter. And it's giving me the what? Area or circumference? Area. Okay. So here's what we have to do. It says the area equals 196 pi, right? Okay. What's the formula for area? Pi r squared. So do you see where it says A or area there? If I take out that area and I replace it with the area formula, pi r squared equals, what did they tell me the area actually was? 196 pi. Does everybody understand what I did? I replaced the word area with the formula for area, and I set it equal to what they told me the area was. What is the only variable that I have in that equation right now? R. Okay. So what we can do is we can solve this thing for R. How do I get R squared by itself? What is next to R? Or R squared? What's next? Pi. Okay. So what we want to do is we want to divide both sides by pi. What are the pi's going to do on both sides? Cancel. So that one's going to cancel, and so is that one. That leaves me with r squared equals 196. No. What did they ask us for? Look in the direction that says find the diameter. So right now, I have that the radius squared is equal to 196. Is that the radius? No. How do I find the radius? Divide by 2. How do you undo a square? Square root. Remember like we do when we do the Pythagorean theorem? So in your calculator, do the square root of 196. Remember that is your second x squared, and then enter 196. Second x squared, and enter 196. if you want the diameter. What is the square root of 196? 14? Second. And then x squared. And then 196. Okay. What do we say? 14. Is that what they asked me for? No, they asked me for the diameter. So you got to be careful what they ask you for. The radius is only halfway through the circle. The diameter is the full way. So how can I figure out what that whole thing is? Multiply by 2. Okay, so do 14 times 2. And so my diameter is going to equal 28. So we had to work backwards to find a missing measurement. That's a good question they like to ask on the EOC, which is less than a month away now. May 8th is when we take that. Are we kind of okay there? Somewhat? Okay. All right, let's look at the next one. Same question. Still looking for the diameter. But this one's slightly different because what does my area not have in it in this one? It doesn't have the pi symbol. Okay, so let's go ahead and start the same. We're looking at this equation here. We're going to replace area with its formula, pi r squared. The process is going to be the same, except for I do not have the pi symbol on both sides. What am I going to need to divide by to get r squared alone? Pi. It does cancel out on the side with the r squared. You need your calculator. Do 915. Everybody put 915 in your calculator. And then hit divided by. And then does everybody see that pi symbol? Okay, hit that pi symbol. We should be following these instructions in the calculator. 915. Divided by that pi symbol. And then hit equals. And let's go to tenths place. Do 915 divided by the pi symbol that's right there on the, hit that, and then hit equals. Okay. To the tenths place, I got 291.3. I got 291.25, so I rounded it up to 291.3. Is that what my radius is equal to? No. I have to do what now? Take the square root. Yep. So let's do that in our calculator. I want you to take the square root of 291.3. Round that to the tenths place as well. So I'll get about 17.1. And then to find the diameter, I'm going to have to do what to that? Multiply by 2. So the diameter is going to be 2 times my radius. 2. If you do 17.1 times 2, 34.2. Okay. I would give you 34.1. Okay, depending on what buttons you hit in the calculator, it could be off by like a tenth place. So I would give, if you had the 34 point either 1, or 2, or 3, I would give that to you.
If the number after, if it's like
Yeah, so what I did though was I rounded the radius. So I just took it as 17.1. I didn't move all that other stuff in the calculator and then multiply that by 2. So if you do just 17.1 times 2. Now if I did what I had in the calculator, that gives me 34.13. This would be 34.1. So it just depends on what. That's why I said I'd give you a 10th place here or there for that one. Is everybody okay with that? Area and circumference of a circle is not very difficult, correct? Okay. Next is a sector. Think about a slice of pizza. That's what a sector of a circle is. It is one section of that. So a sector is a region of a circle bounded by a central angle and its intercepted arc. I'm going to let you fill that in. A sector is a region of a circle bounded by a central angle and its intercepted arc. Okay, and it says, think of a slice of pizza. Here's my pizza. Everybody see my pizza? This is my central angle. The crust is my arc. Okay, so those are the parts that we're referring to. Think of a slice of pizza. Most of us eat it with the skinny part first. So you eat the central angle, right? The crust, the dipping stuff we dip in our sauces, is our arc. Everybody understand what I'm talking about? All right. The area of a sector, the area of a sector of a circle represents just a fraction of the entire circle. Okay, not the whole circle, but the fraction of the entire circle. So think about your whole pizza, your one slice. That is just a fraction of that pizza. So here is the formula for area of a sector. It is x over 360. It is a fraction. Times pi r squared. Let's break that down. Pi r squared is the formula for area of a circle, okay? And then there is a fraction. Why do you think 360 is involved? That's a circle, yes, exactly. That's the number of degrees in a circle, 360, right? Yes? So in this formula, x is representing my central angle. That's not supposed to say arc. Scratch out arc and say central angle. Okay. And r is the radius of the circle. Okay, x is the measure of your central angle. So whatever this angle is right here. And then r would be the radius of your circle, which is one edge of your pizza, or slice of pizza. Okay, we're going to really need to use our calculators for these fractions. Is everybody ready? Looking at my first sector, does everybody see the shaded part in your picture? That's my piece of pizza. What is the central angle there? The angle that is in the center, the first bite of my pizza is how many degrees? 51. So this is what we're going to do. We're going to go 51 over 360. We're just setting it up right now. Equals pi. Now, what else does it tell me above my picture? It tells me that BC is 16. Is that my radius? Yeah. Okay. So we're going to go 16 squared. Are you ready? This is why I need you to follow instructions. This is how you simplify these to get the correct answer in exact form the easiest way possible. Everybody type in the number 51 in their calculator. And then you want to find your fraction key, the one that says ABC. Everybody find the fraction key? Hit that button. Then type in 360. And then hit equals. ABC right now? Because we want to leave it in fraction. So do 51. And then your 360. And then hit equals. Did everybody get a fraction in your calculator? What is that fraction? Okay. What we did was we just reduced 51 over 360. So far, so good. All right, the next thing I want you to do is 16 squared. $16 squared. 16 times 16. How much? 256. Okay. I'm going to put that over 1. Now, do 17. $17 times 256 is what you need to do in your calculator. What does that give us? 4,352. All right, put pi behind it. Okay, what we're doing is we're just multiplying our fractions straight across. What is 120 times 1? 120. Okay. Now, we're not quite finished because we might can still simplify this. We're going to rely on our calculator a lot. Is everybody ready? Okay. Do 352. In your calculator, 4352. Hit your fraction key and hit 120 and hit equals. And then let me ask you this. Did y'all get something that looks like that in your calculator? That's a mix up. Okay. So here's the thing. We're going to use our calculator again. This is 36 and the fraction 4 over 15. So what I want you to do now, leave that in your calculator screen. Hit second. Hit your fraction key again. And then hit equals. Does that give you a new fraction? Okay. 544 over 15. And then the only thing I have left to do is what did I leave out of the whole process? The pi. So we're going to stick a pi at the top. And that's how we want to leave these in exact form. Okay, so you're going to rely heavily on the calculator, especially with these fractions. Sometimes you will end up getting a whole number and it won't be a fraction because it'll work out nice and neat. But sometimes it's not so nice and neat. Are we ready to try another? Okay. Let's go to our formula. What is my central angle for number 2? 139 over 360
Okay.
Talking about like a piece of pizza, that we're finding the area of that one slice of pizza. So it's a fraction of the entire circle.
Would you just subtract and be like, that's, oh, we do it.
Right. What is my radius? 22? At the top. All right, let's do our fraction first. If I start going too fast, let me know. Do 139 over 360. Let's see if that reduces. I want to show you this. If you enter the fraction 139, your fraction key 360, and you hit equal, it doesn't change, does it? That means it doesn't simplify. 139 and hit your fraction key. Yep. 360. It's the same thing, right?
Yeah, same thing.
Okay, so that means, all that means is that part does not simplify. So we're just going to rewrite it. Now we're going to go 22 squared. And don't forget. And again, we're going to put that over 1. Then we're going to go straight across. Do 139 times 484. We get a large number. What's 360 times 1? But we're going to use our calculator to see if this reduces. Okay, so same process. We want to write.
I got 186.87777778.
All right, 67276, fraction bar, 360 and equals. Is that what you got in the calculator? Yep, and then we're going to change it again. So we go second, fraction key, and equals, and that will change us to a better fraction.
Any breeze? I got. Did I do this one? You got to do it.
Look, this is exactly what you hit in the calculator. Hit this number, hit that key, hit that number, hit equals.
I got this.
You got that, right?
Yeah. 186.
Okay, so then hit second, your fraction key, and equal again.
Oh.
We're just letting the calculator do all the reducing for us.
And we do it again after that. That's the way.
Once you do it in here, it won't simplify anymore. Is everybody okay with that? Flip it over. I'm going to try to get through at least one of these. Hold on. Okay, we're going to just do the first one. Everybody ready? Actually, you know what? Let's do the second one just so I have more room to work. Okay, just cross out that first one. We're not going to do it. We'll do the second one. Okay, we got to go quickly. It tells me the area of a sector has an area, one sector of a circle has an area of 121 square centimeters. Okay, so the area is equal to 121. And then it says the arc measure, which is also the central angle measure, is 36. So in my formula, that's the x. We want to find the area of the circle. Everybody ready? Okay. So think about this. The formula for area of a circle is x over 360 times pi times radius squared, right? What did they tell me the area was? So I'm replacing A with 121. What did they tell me my arc was? 36 over 360. Now, before we keep going, let me ask you a question. This right here, this pi r squared, isn't that the formula for area of a circle? So if I can maybe just get that fraction over to the other side, I already have the area of the circle without having to find the radius and go backwards, right? Okay, so let's do this. How can I get rid of that fraction? If I want to get rid of the denominator, I would multiply both sides by 360. Okay, so start by this. Multiply. I'm showing you the work, but we're basically just multiplying both sides by 360. What that does is over here on the right side, those 360s cancel each other out. And that leaves me with 36 times pi times radius squared. And then I need you to do in your calculator 121 times 360. What does that give us? 43,560. So let's write that down. So right now I have 43,560 equals 36 pi r squared. If I want that pi r squared to be by itself, what do I need to get rid of next? What number is next to pi r squared? What number is next to pi r squared right there? 36. So how do I get rid of it? Divide. So divide both sides by 36. What answer did we get, or what number did we get? 1,210. Those cancel. And 1,210 is equal to pi r squared. Isn't that what the area of a circle is? So guess what my answer is? Very good. We will review tomorrow. We will quiz on Thursday.
Oh. Is this multiplication anymore?
Right, your phones, just meet me by the door. If you haven't gotten your phone, just come by and collect it from me. I got it right here. Sorry.
All right. God, this thing is trippy. What the fuck? Why you had to do all that?